April 15th, 1943. 200 miles northeast of the Solomon Islands, the Pacific stretched like hammered steel under a cloudless sky. Aboard the destroyer USS Fletcher, radio man second class Thomas McKenna stood in the cramped communications room, surrounded by the hum of vacuum tubes and perpetual crackle of static that had become the soundtrack of his war. Outside, the convoy crawled northwest at 12 knots. 17 merchant ships loaded with ammunition, fuel, and medical supplies desperately needed at Guadalcanal. Above deck, Lookout scanned the horizon with binoculars, searching for the periscope feather that meant death. Below, sonar operators listened through headphones for the telltale ping return that would announce a submarine lurking in the depths. But McKenna knew something the rest of them had not yet accepted. The ocean had learned to hide its predators too well. He was 23 years old, lean and angular, with oil-stained fingers and the permanent squint of someone who spent too many hours staring at glowing dials in darkened rooms. Before the war, he had been a radio hobbyist in Portland, Oregon, spending his evenings in a basement workshop building crystal sets and experimenting with antenna designs. His father, a tugboat engineer, had taught him to think in systems, to see invisible connections between cause and effect. His mother, a piano teacher, had given him an ear for patterns, for the subtle harmonics that most people missed. When Pearl Harbor burned, McKenna had enlisted immediately, volunteering for radio school because it was the only part of the Navy that made sense to him. Guns were brutal and straightforward. Engines were hot and deafening. But radio was invisible magic, messages riding electromagnetic waves across impossible distances, and McKenna had always believed that the invisible world held secrets the visible one could never touch. The problem started 3 months earlier, during convoy duty along the New Guinea coast. A Japanese submarine, later identified as I-17, had shadowed their formation for 16 hours, surfacing at night to radio encrypted position reports back to Rabaul. Every sonar sweep came back empty. The submarine commander found a thermal layer, a boundary where warm surface water met cold deep water, and tucked his boat just beneath it. Sound waves bent along that boundary, refracting away from the surface like light through a prism, creating an acoustic shadow where submarines became invisible. The convoy lost 2 freighters at night, torpedoed from a ghost that sonar could not touch. McKenna had stood on deck afterward, watching oil fires burn on the water, listening to the screams of men in the darkness, and felt the impotent rage of someone who possessed tools that no longer worked. Standard doctrine said that radio direction finding could locate enemy transmissions, allowing escort destroyers to triangulate the source and drive the submarine down before it could attack. The equipment was straightforward, a loop antenna mounted on a rotating platform, connected to a receiver that measured signal strength. When the loop was perpendicular to the incoming signal, the antenna received maximum power. When parallel, it received minimum. By rotating the loop and noting the angles of maximum and minimum signal, an operator could draw 2 lines on a chart and find the transmitter at their intersection. It was elegant, reliable, and almost completely useless against submarines that had learned not to transmit until after they attacked. But McKenna had noticed something strange during that convoy run. Late at night, when most transmissions went silent, he sometimes heard faint low-frequency hums on his receiver, barely perceptible oscillations that did not match any known signal. They were too regular to be atmospheric noise, too faint to be intentional transmissions. He mentioned them in his log, but the communications officer dismissed them as electrical interference from the ship's generators or perhaps distant lightning. McKenna accepted the explanation because he had no alternative, but the sounds bothered him, lingering in his memory like a melody he could not quite place. 2 weeks later, during a port call in Noumea, McKenna found himself in a dockside bar talking to an Australian engineer named Harris, who had worked on submarine electrical systems before the war. Harris was 50-something, weathered and cynical, and after 4 whiskeys he started talking about the unintended radiation that submarines produced. Every electric motor, every generator, every piece of rotating machinery created electromagnetic fields. Most of that energy stayed contained within the hull, but some of it leaked into the water, especially through the periscope and radio masts when they were raised. It was incredibly faint, Harris said, almost undetectable, but it was there. Japanese submarines used particularly noisy electric motors for submerged propulsion, older designs that had not been as carefully shielded as American models. If someone could build a sensitive enough receiver and point it in the right direction, Harris said they might be able to detect a submarine even when it was running silent beneath a thermal layer. Then he laughed, a bitter sound, and said it was impossible because the signal would be too weak and the noise from the ship's own electrical systems would drown it out completely. McKenna listened and said nothing, but his mind was already racing through circuit diagrams and antenna theory. That night, back aboard the Fletcher, he sat in his bunk with a notebook and started sketching ideas. The problem was sensitivity. A standard loop antenna was designed to receive relatively strong signals from distant transmitters. It had a narrow frequency response and limited gain at the low frequencies where electromagnetic leakage from submarine machinery would appear. To detect something so faint, he would need an antenna that was far more sensitive to low-frequency signals, something that could amplify the subtle harmonics that conventional equipment missed. He thought about his amateur radio experiments before the war, particularly his work with small-loop antennas for receiving low-frequency natural radio signals, the whistlers and tweaks produced by lightning strikes propagating through the Earth's magnetosphere. Those antennas had been wound differently, with more turns of wire and a different capacitance matching network. But there was another trick he had stumbled on accidentally during those experiments, something he had never fully understood. One night, while troubleshooting a loop antenna that was not performing as expected, he discovered that he had accidentally reversed the wiring. Instead of connecting the loop output to the receiver input in the standard configuration, he had crossed the connections, creating what electrical engineers would call a phase reversal. To his surprise, the antenna had not stopped working. Instead, it had started picking up signals it had never received before, low-frequency hums and pulses that seemed to come from nowhere. At the time, McKenna had assumed he was hearing electrical noise from nearby power lines or household appliances. He had corrected the wiring and moved on. But now, sitting in his bunk aboard the Fletcher with a memory of burning ships in his mind, he wondered if that accidental reversal had done something more interesting. Antenna theory said that. Reversing the phase should not fundamentally change what the antenna received. But theory was built on idealized mathematics that assumed perfect components and ignored real-world complexities. What if reversing the wiring created some kind of resonance with the water itself, some interaction between the electromagnetic field and the conductive seawater that amplified low-frequency signals? It sounded absurd, the kind of pseudo-scientific nonsense that got amateur radio operators laugh out of engineering conferences. But McKenna had learned to trust his hands more than textbooks, and his hands remembered that reversed antenna picking up signals it should not have received. The next morning, he requested permission to modify the direction-finding loop antenna for experimental purposes. The communications officer, Lieutenant Davis, was a by-the-book academy graduate who believed that equipment should be operated exactly as designed and that improvisation was a sign of inadequate training. He denied the request immediately. McKenna tried to explain his theory about detecting submerged submarines through electromagnetic leakage, but Davis cut him off, saying that if such detection were possible, the Navy's research laboratories would have already developed it, and that radio men should focus on receiving messages rather than inventing imaginary technologies. The conversation ended with a direct order. The direction-finding equipment would remain in its standard configuration, and McKenna would log any further unusual signals, but take no action beyond reporting them through proper channels. McKenna saluted and returned to his station, but the idea would not leave him alone. Every time he put on his headphones and heard the static hiss of the receiver, he imagined submarines sliding to the darkness below, invisible to sonar, unstoppable because the Navy refused to try something that textbooks said should not work. He thought about the men screaming and burning oil and the cargo ships sinking with enough ammunition to supply an entire division. He thought about his father saying that the difference between an engineer and a mechanic was that a mechanic fixed what was broken while an engineer fixed what did not exist yet. And he made a decision that would either save lives or end his career. He waited 3 days, until the convoy was 2 days out of port and far enough from land that no one would question atmospheric interference patterns. The midnight watch was the quietest, with minimal radio traffic and the communications officer asleep in his cabin. McKenna told the other radio man on duty a kid from Kansas named Jennings, that he needed to perform routine maintenance on the direction-finding antenna. Jennings shrugged and went back to monitoring the fleet tactical frequency. McKenna opened the equipment cabinet and looked at the wiring harness that connected the loop antenna to the receiver. His hands were steady. He had done this kind of work 1,000 times before, in his basement workshop and in radio school and in a dozen different shipboard systems. But he had never deliberately violated a direct order from an officer, and he had never modified military equipment in a way that might be considered sabotage if things went wrong. He disconnected the antenna leads and reversed them, swapping connections so that the signal entering the receiver was phase-inverted relative to the standard configuration. Then he adjusted the matching network, changing the capacitance values to compensate for the altered impedance. The entire modification took 11 minutes. When he was finished, the antenna looked exactly the same from the outside, and the receiver operated normally on standard frequencies. But now, at the low end of the spectrum, below 30 kilohertz where submarine machinery harmonics would appear, the system was transformed into something the Navy had never intended and electrical theory said should not matter. He did not tell anyone. He logged into his notebook that he had performed routine maintenance, which was technically true, and he went back to his normal duties. For 2 days, nothing changed. The convoys steamed northwest. The sonar operators listened to empty ocean, and the radio traffic consisted of routine position reports and weather updates. McKenna monitored the low-frequency bands during his watches, listening for the faint hums he had heard before, but the receiver remained silent except for the usual atmospheric noise. He began to wonder if he had wasted his effort, if the reverse antenna was just a placebo built from desperation and wishful thinking. Then, on the third night, at 0 to 30 hours, he heard it, a low-frequency oscillation, barely perceptible above the background noise, pulsing at roughly 12 cycles per second. It was not atmospheric. It was not electrical interference from the ship. It had structure, a rhythmic quality that suggested rotating machinery. McKenna turned the direction-finding loop slowly, watching the signal strength meter on the receiver. The signal peaked when the loop pointed 30 degrees off the port bow. He rotated past the peak and watched the meter drop, then come back up as he continued around, creating the characteristic figure-8 pattern of a directional antenna. He had a bearing. Something out there, roughly 20 miles away based on the signal strength, was producing low-frequency electromagnetic radiation consistent with electric motors operating underwater. His heart hammered against his ribs. He rechecked everything, verifying that the receiver was tuned correctly and that the antenna was rotating freely. The signal remained, faint but unmistakable. He plotted the bearing on the chart and saw that it pointed into empty ocean, an area where the convoy had not yet traveled. If the signal was real, if it was actually coming from a submarine, then that submarine was positioning itself ahead of the convoy, waiting in ambush exactly as I-17 had done 3 months earlier. McKenna stared at the chart and felt the weight of the decision crushing down on him. If he reported this to Lieutenant Davis, the officer would demand to know how McKenna had detected a signal that standard equipment should not receive. The reversed antenna would be discovered. McKenna would face disciplinary action for disobeying orders and modifying military equipment without authorization. His radio career would be over, and in wartime, equipment tampering could even be prosecuted as sabotage. But if he said nothing and the submarine attacked, 17 ships would steam into a killing zone that McKenna had seen but failed to warn them about. Hundreds of men would die. The ammunition and fuel they were carrying would go to the bottom, and the Marines at Guadalcanal would face Japanese counterattacks without the supplies they needed to hold the island. McKenna closed his eyes and saw his father standing in their basement workshop, holding a broken radio, and saying that being right did not matter if you were too afraid to turn on. He opened his eyes, took a deep breath, and reached for the sound-powered phone that connected to the bridge. The officer of the deck was Lieutenant Commander Reeves, the Fletcher's executive officer, a former merchant marine captain who had been called back to active duty and given a destroyer because the Navy needed experienced ship handlers more than it needed academy pedigrees. Reeves had a reputation for listening to his enlisted men, but he also had a reputation for not tolerating nonsense. When McKenna explained that he detected a possible submarine contact using the radio direction finder, Reeves's first question was direct. What frequency? McKenna told him. Reeves was silent for a moment, then said, Radio direction, finders don't work on frequencies that low. What are you actually hearing? McKenna hesitated, then explained the theory about electromagnetic leakage from submarine machinery. Reeves asked if this was something the Navy had trained him to detect. McKenna said no. Reeves asked if Lieutenant Davis knew about this. McKenna said he had requested permission and been denied. Another silence, longer this time. Then Reeves said, Come to the bridge. Bring your logbook. McKenna climbed the ladders to the bridge, his notebook clutched in one hand, expecting to be arrested the moment he arrived. Instead, he found Reeves standing at the chart table with the navigator and the captain, Commander Hayes. Hayes was 42, a career officer who had commanded destroyers in the Atlantic before being transferred to Pacific. He had a lined face and calm eyes that had seen too many men die. When McKenna entered, Hayes looked up and said, Show me what you heard. McKenna spread his notebook on the chart table and explained the signal, the frequency, the bearing, the rhythmic pulsing that suggested rotating machinery. He did not mention the reversed antenna. Hayes studied the chart, then turned to the sonar officer, who had been summoned to the bridge. Sonar contact in that area? The sonar officer shook his head. Negative, sir. We've been pinging that sector every 10 minutes. If there's a submarine there, it's below a thermal layer. Hayes nodded slowly. He looked at McKenna. You're telling me you can detect a submarine with a radio antenna when sonar can't? McKenna met his eyes. I'm telling you I'm hearing something that matches the signature of submarine electrical systems, and it's on a bearing ahead of the convoy. I could be wrong. But if I'm right, we're about to sail into an ambush. Hayes was silent, his fingers drumming on the chart table. The bridge was quiet except for the hum of ventilation and the distant thrum of the engines. Finally, Hayes turned to Reeves. Alter course 15 degrees to port. Increase speed to 20 knots. We'll investigate this contact before the convoy reaches that position. Reeves repeated the orders to the helmsman. The Fletcher heeled slightly as it turned, the deck tilting beneath McKenna's feet. Hayes looked at McKenna again. You stay on that radio. If your signal gets stronger or changes bearing, you tell me immediately. McKenna nodded and returned to the communications room, his hands shaking now that the adrenaline was fading. Jennings stared at him. What the hell is going on? McKenna sat down at the receiver and put on his headphones. I don't know yet, but we're about to find out. The Fletcher raced through the darkness, its bow wave glowing with bioluminescence. McKenna monitored the signal, watching it grow stronger as they closed the distance. The bearing remained steady, confirming that the source was stationary or moving very slowly. At 0315, the signal strength peaked, indicating that they were nearly on top of the source. McKenna reported to the bridge. Hayes ordered the ship to slow and the sonar crew to go active, sending powerful pings into the water. For 2 minutes, nothing. Then the sonar operator's voice crackled over the intercom, tense and sharp. Contact! Submerged target, bearing 352, range 800 yards, depth 150 feet. The bridge exploded into controlled chaos. Hayes barked orders, and the Fletcher surged forward, closing the range. The fire control team calculated the target's position. Depth charges were rolled to the stern rails, set to detonate at 150 feet. At 0320, the first pattern dropped, 6 charges tumbling into the black water. McKenna felt the explosions through the deck, massive underwater concussions that rattled the ship's frame. The sonar operator reported the target breaking up, mechanical noises and high-pressure air hissing into the water. At 0323, debris surfaced, with planks, oil slicks, pieces of clothing, and a life ring stenciled with Japanese characters. Hayes stood at the bridge window, watching the debris field expand in the Fletcher's wake. He turned to Reeves. Have a radio man report to my cabin. McKenna's stomach dropped. He had sunk a submarine, but he had also disobeyed orders, and now he would face the consequences. He climbed to the captain's cabin, knocked, and entered. Hayes sat behind his desk, his face unreadable. Sit down, McKenna. McKenna sat. Hayes leaned back in his chair. That submarine would have been in perfect position to ambush the convoy at dawn. You saved 17 ships and probably 1,000 men. Now tell me how you actually did it." McKenna explained everything. The faint signals he had heard, the conversation with the Australian engineer, the theory about electromagnetic leakage, and finally, the reversed antenna wiring. Hayes listened without interrupting. When McKenna finished, Hayes was silent for a long time. Then he said, "You directly disobeyed Lieutenant Davis's order. You modified military equipment without authorization. In peacetime, I'd have you court-martialed." He paused. "But this isn't peacetime, and you just proved that sometimes a book is wrong." He opened a drawer and pulled out a blank sheet of paper. "I'm going to write a report recommending that the Navy research your detection method and consider equipping escort ships with modified direction-finding antennas. I'm also going to recommend you for a commendation. But first, you're going to restore that antenna to its original configuration, and you're not going to modify any more equipment without written permission from me personally. Understood?" McKenna nodded. "Understood, sir." Hayes signed the paper and looked up. "Get out of here before I change my mind." McKenna returned to the communications room in a daze. Jennings was waiting, eyes wide. "Did you really find a submarine with a radio?" McKenna sat down and started restoring the antenna, wiring to its standard configuration, as ordered. "I got lucky," he said. But even as he reconnected the leads in their original positions, he was memorizing the exact modifications he had made, sketching in his mind so he could reproduce them later if permission ever came. Word of the sinking spread through the Fletcher within hours. By morning, every enlisted man aboard knew that a radio man had detected a submarine that Sonar had missed. The story grew with each retelling, acquiring details that McKenna had never mentioned. The submarine had been Japanese. It had been stalking the convoy for days. McKenna had heard its engines through walls of water that bent sound waves into useless circles. The sonar operators were defensive, insisting that they had made the actual kill and that McKenna's signal had only provided an initial bearing. The radio gang was triumphant, declaring that radiomen had finally proven their worth in submarine warfare. McKenna stayed quiet and focused on his work, monitoring frequencies and logging transmissions, trying to process what had happened. Commander Hayes filed his report with the task force commander, and the task force commander forwarded it to Pacific Fleet headquarters with a note saying that unconventional detection methods deserved investigation, given the increasing losses to submarine attack. The report sat in someone's inbox for 3 weeks, then was forwarded to the Naval Research Laboratory in Washington with a request for technical evaluation. An engineer at the laboratory read McKenna's description of the reversed antenna and wrote a 3-page response explaining that phase inversion should not affect low-frequency sensitivity and that the reported detection was most likely coincidental, possibly caused by the submarine briefly raising a mast and transmitting a short signal that McKenna had happened to intercept. The engineer concluded that further investigation was not warranted. The report was filed and forgotten. But McKenna's method did not die because it was not built on theory or official approval. It was built on results, and results spread through unofficial channels faster than paperwork ever could. 3 other radio men aboard the Fletcher asked McKenna to show them what he had done. He explained the modification quietly, during off hours, sketching diagrams in notebooks and describing the signal characteristics to listen for. 2 of them tried it and heard nothing. The third, a radio man named Sullivan from a Tennessee farm who had built his own radio station at age 14, heard the same faint oscillations McKenna had detected. When the Fletcher returned to Noumea for resupply, Sullivan mentioned the technique to a radio man aboard another destroyer. That radio man tried it during the next convoy run and detected a submarine contact 12 miles ahead of the formation. The submarine was attacked and damaged, forced to surface, where aircraft sank it the following morning. Word spread. By June, radio men on 8 different escort destroyers had modified their direction-finding antennas and were monitoring low-frequency bands for electromagnetic signatures. Not every operator could hear the signals. It required a particular kind of ear, the ability to distinguish faint patterns from background noise, the patience to listen to static for hours waiting for something that might never appear. But the ones who could hear it started racking up detections. Japanese submarines operating in the Solomon Islands and along the New Guinea coast found that their ambush positions were being discovered before they could attack. Convoys altered course based on radio bearings, forcing submarines to reposition and often exposing themselves to sonar or air patrols in the process. Losses dropped. The Japanese Navy noticed. Intelligence officers analyzing American convoy movements detected a pattern. Escort destroyers were avoiding submarine patrol areas with uncanny accuracy, as if they possessed foreknowledge of Japanese positions. Interrogations of captured American sailors revealed rumors about radio men detecting submarines through electromagnetic emissions, but the reports were dismissed as disinformation or sailor superstition. Japanese engineers insisted that their submarines' electrical systems were adequately shielded and that underwater electromagnetic propagation at low frequencies was too limited for practical detection. But the sinkings continued to decrease, and Japanese submarine commanders grew increasingly frustrated with the Americans' ability to avoid or preempt their attacks. In August, a staff officer at Pacific Fleet headquarters noticed the unusual number of submarine contacts being reported by escort destroyers based on radio bearings. He pulled the original report Commander Hayes had filed in April and reread it carefully. Then he contacted the Naval Research Laboratory and requested a formal experimental evaluation of reversed antenna configurations for low-frequency detection. The laboratory reluctantly agreed to conduct tests. In September, engineers built a modified direction-finding antenna according to McKenna's specifications and tested it near submerged American submarines operating in Chesapeake Bay. The initial results were inconclusive. The test submarines' electric motors were better shielded than Japanese models, and a controlled environment did not replicate the complex acoustic and electromagnetic conditions of actual combat. The engineers wrote a report concluding that the technique showed limited potential under ideal conditions and recommended against fleet-wide implementation. But in the Pacific, the technique continued to prove itself. By October, radio men had developed refinements, optimal frequency bands to monitor, signal processing tricks to distinguish submarine signatures from atmospheric noise, protocols for cross-checking bearings with other ships in the formation. The method was imperfect. False contacts outnumbered real ones by roughly 3-1. But even a 30% success rate was infinitely better than zero, and in convoy warfare, a single prevented ambush could mean the difference between safe passage and catastrophic losses. Lieutenant Davis, who had forbidden McKenna to modify the direction-finding antenna, never acknowledged the technique's success. He was transferred to shore duty in November and spent the rest of the war at a communications training facility in California, teaching radio men to operate equipment exactly as designed. Commander Hayes was promoted to captain and given command of a cruiser. In his fitness report for McKenna, he wrote, "Radio man McKenna demonstrates exceptional technical initiative and creative problem-solving. His unauthorized equipment modification violated procedure, but saved multiple ships and cargo. Recommended for advancement and technical specialist training." McKenna was promoted to Radio Man First Class in December and transferred to a newly formed unit developing advanced radio and radar techniques for submarine detection. The reversed antenna technique never became official doctrine. The Naval Research Laboratory's lukewarm assessment prevented it from being incorporated into training manuals or standard operating procedures. But it persisted as an informal practice among escort radio men, passed from sailor to sailor through demonstration and shared experience. After the war, when historians compiled records of anti-submarine warfare in the Pacific, they focused on sonar improvements, air patrols, code breaking, and tactical innovations. The reversed antenna received no mention in official histories because it had never officially existed. McKenna's name appeared in no citations, no commendations beyond a single paragraph in his fitness report. When he mustered out in 1946, he returned to Portland, opened a radio repair shop, and never spoke publicly about the war. But the story survived in other ways. In 1968, a Navy electronics technician named Roberts, researching low-frequency electromagnetic detection for a graduate thesis, discovered Commander Hayes' original report in a box of unsorted documents at the National Archives. Roberts tracked down McKenna, who was then 63 and still running his repair shop. Over a series of interviews, McKenna explained the technical details of the reverse antenna and the reasoning behind his modifications. Roberts included the story in his thesis, which was published in an obscure naval engineering journal and read by approximately 40 people. One of those readers was a sonar engineer working on modern submarine detection systems. The engineer recognized that McKenna's intuition about phase reversal and low-frequency sensitivity had been essentially correct, even if his theoretical explanation had been incomplete. Modern electromagnetic theory, developed decades after World War II, had revealed subtle nonlinear interactions between antenna fields and conductive media, like seawater, that could indeed enhance low-frequency reception under certain conditions. McKenna had stumbled onto a real phenomenon, not through mathematics, but through hands-on experimentation and willingness to try something that textbooks said should not matter. That engineer wrote a paper exploring historical precedents for unconventional detection methods, citing McKenna's work as an example of empirical discovery preceding theoretical understanding. The paper circulated among defense researchers and inspired new investigations into electromagnetic submarine detection. By the 1980s, advanced systems were being developed that used sensitive magnetometers and extremely low-frequency antennas to detect the faint electromagnetic signatures of submerged submarines. These systems bore little resemblance to McKenna's improvised modification, but they were built on the same fundamental insight. Submarines could not be perfectly invisible, and the tools to find them often came from unexpected places. McKenna died in 1994, largely forgotten except by a handful of naval historians and the veterans who had served with him aboard the Fletcher. His obituary in the Portland newspaper mentioned his radio repair business and his Navy service, but said nothing about submarines or detection methods. The reversed antenna technique he had invented under threat of court-martial had saved an unknown number of ships and lives during the last 2 years of the Pacific War, but that story existed only in scattered reports, fading memories, and the thesis of a graduate student that almost no one had read. Yet the principle he had demonstrated remained vital. That warfare drove innovation not through careful planning and official research programs, but through desperate improvisations by ordinary men facing immediate threats with inadequate tools. The greatest inventions emerged not from laboratories, but from the moment when doctrine failed and someone decided to try something that should not work. McKenna had been a radio hobbyist from Portland who liked to take things apart and wire them differently to see what happened. He had reversed 2 wires because a half-remembered accident suggested it might matter. He had violated orders because saving lives seemed more important than following procedures. And for a brief period in the Pacific War, his forbidden modification had given American convoys a crucial edge against an enemy that believed itself undetectable. The submarine he sank on April 18, 1943, was later identified through Japanese records as I-22, a fleet submarine that had departed Rabaul 5 days earlier with orders to intercept American supply convoys northeast of Guadalcanal. The boat's commander, Lieutenant Takashi Yamamoto, was an experienced officer with 4 successful patrols and 11 confirmed ship sinkings to his credit. He had positioned I-22 beneath a reliable thermal layer, confident that American sonar could not reach him, and that he would remain invisible until the moment he chose to attack. He never knew that a radio man with reversed antenna wiring had heard the faint electromagnetic whisper of his boat's electric motors and drawn a bearing that led destroyers directly to his position. I-22 went down with all 47 crew members, and the convoy that had been stalking reached Guadalcanal intact. In the decades after the war, naval technology advanced far beyond anything McKenna could have imagined. Satellites tracked submarines from space. Nuclear-powered attack submarines hunted each other in silent games of acoustic hide-and-seek beneath polar ice. Computer algorithms processed sonar data in milliseconds, distinguishing biological sounds from mechanical ones with inhuman precision. But the fundamental challenge remained unchanged. The ocean was vast and deep and filled with layers and shadows where things could hide. Detection required not just sophisticated equipment, but also the human instinct to listen for patterns that should not be there, to trust intuitions that textbooks could not explain, and try reversing the wires when everything else had failed. McKenna's story faded into obscurity not because it was unimportant, but because it was uncomfortable. It suggested that official doctrine could be wrong, that unauthorized modifications could be necessary, that survival sometimes required disobedience. Military institutions preferred narratives of careful planning and proper procedure, of innovations emerging from research laboratories rather than improvised in the field by sailors violating orders. Acknowledging McKenna's contribution would have meant acknowledging that the Naval Research Laboratory had dismissed his technique, that Lieutenant Davis had forbidden potentially life-saving experimentation, that the official system had failed while an individual with a screwdriver and a hunch had succeeded. So the story was forgotten, buried in unsorted archives and obscure theses, known only to the few who bothered to look beyond official histories. But a lesson remained, whether anyone remembered it or not, that the difference between victory and defeat often came down to one person willing to reverse the wiring and listen for signals that should not exist, even when everyone with authority said it was impossible, and even when success meant risking everything for an idea that might be completely wrong. McKenna had made that choice on a destroyer in the Pacific darkness, and 17 ships had reached port because of it. That was the only recognition he had ever needed, and the only legacy that truly mattered